Tashidilek everyone. In this video we are going to discuss about the factorization of the polynomial, and under that we are going to study about the factorization of the quadratic polynomial and then followed by the factorization of the cubic polynomial. So first of all, let us understand what is factorization. Now factorization means the expressing the given polynomial as a product of its two factors. For example, if I write 3x square, now 3x square can be written as 3x into x, or it can be written as 3 into x into x. So these are the factors of the given polynomial or the monomial 3x square. So this process is called the factorization. So now we'll discuss how to factorize the quadratic polynomial. Now first one is the general form of the quadratic polynomial, and the general form of the quadratic polynomial is ax square plus bx plus c. Now here a is the coefficient of x square and b is the coefficient of x and c is the constant term. Now this is the general form, and there should be one condition that a should not be equal to 0, where a, b and c are any real number, and a should not be equal to 0. Now what happens if a equal to 0? Now if a is equal to 0, that means 0 in 0x square plus bx plus c. Now 0 into x square is 0, so we are left with bx plus c. Now bx plus c is not a quadratic polynomial, since the highest power of the variable in this case is not equal to 2. So this is not a quadratic polynomial, and this is a linear polynomial. So here we are discussing about the quadratic polynomial. Now it is mandatory to have the highest power of the variable as 2. Now let's take an example here. Here we have a quadratic polynomial x square plus 3x plus 2. Now in the last video we have learned about the factor theorem. So here we'll use the factor theorem to factorize this polynomial, and at the same time we'll use the splitting the middle term method that we have learned in class 8. So let's try with the factor theorem first. So we'll write the given polynomial, that is p of x is equal to x square plus 3x plus 2. Now to use the factor theorem, very important thing to be noted is you have to write down the factors of 2. Now here the coefficient of x square is 1 and coefficient of x is 3 and the constant term is 2. So now you have to take all the factors of 2. So we'll write down the factors of 2. Now factors of 2 are, we have plus or minus 1 and plus or minus 2, isn't it? So now what we have to do is, now if you recall the factor theorem states that x minus a is a factor of p of x if p of a equal to 0. Now this is the first condition, and in the second part of the factor theorem it has stated that if p of a equal to 0, then x minus a is a factor. So here we are going to use the second part. We are going to find the value of the given polynomial at different value of x, and let's see whether it gives 0 or not. If the answer is 0, then we can say that x minus a is a factor. So let's try with the different value of x here. Okay, let me drop this part, and hope you are clear with the factor theorem if you have watched the last video. So we'll take p of, now let's take p of 1. If you put x equal to 1, then let's see what is the value of given polynomial. That is 1 square plus 3 into 1 plus 2, which is equal to 1 plus 3 into 1 is 3 plus 2. Obviously it is not equal to 0. 3 plus 1 is 4 and 4 plus 2 is 6. So let's take P of minus 1, which is equal to minus 1 square plus 3 into minus 1 plus 2, which is equal to minus 1 squared is plus 1 and plus into minus is minus. 3 into 1 is 3 plus 2. Now this is equal to 1 minus 3 is minus 2 plus 2. This is equal to 0. Here we are getting 0. Now here we can say that x plus 1 is a factor because x equal to minus 1 is 0. Now to understand this, let's say now if I put x equal to minus 1, then the given polynomial becomes 0. Now if you move minus 1 towards the left hand side, you will get x plus 1. So x plus 1 is the factor. You got one factor. Let's find the another one. So let's say P of minus 2, which is equal to minus 2 square plus 3 times minus 2 plus 2. Minus 2 square is plus 4 and plus into minus is minus. 3 into 2 is 6 plus 2, which is equal to 4 minus 6 is minus 2 plus 2. So they get cancelled. You'll get 0. Again we can say x plus 2 is a factor. Therefore when you factorize this polynomial, you will get x plus 1 and x plus 2, that is product of its two factors. We have expressed this polynomial as a product of its two factors. This is how we factorize by using the factor theorem. Now let's try to use the splitting the middle term method. Now in the given quotient, that is x square plus 3x plus 2. Now middle term is 3x. Now here, yes, a very important thing to keep in mind is whenever you are dealing with the polynomial, it is very important that you arrange the given polynomial or the terms in the given polynomial in the descending order of its powers. That means, for example, if I have a questions like for example 2 plus 3x square minus x. Now this is the question. Now here the problem here is terms are not arranged in the descending order of its powers or the power of the variables. Now here the highest power of the variable is 2. So we'll write 3x square first and then followed by the next highest power, that is x power 1. We'll write minus x and then followed by the plus 2. Here the variable power is 0. For the constant term, power of the variable is always 0. Now this is how we rewrite the given polynomial. Now it is very important. Now in quadratic polynomial, now let's go back to our problem here. Here p of x equals, now this is already arranged in the descending order of its powers, and 3x is the middle term. We have three terms here, so the middle one is 3x. So to use the splitting the middle term, what we have to do is we need to split this middle term, that is 3x. So you need to find two numbers whose sum is 3. Here it is positive plus 3, and at the same time you have to keep in mind that when you multiply those two numbers, that is these two numbers, when you multiply it, you should get 2. So now we have 1 into 2 is 2. So 1 plus 2 is 3. We are getting this sum as well as product. Therefore, I can write the given polynomial as x square plus, so instead of 3x, I can write 2x plus 1x. So when you add these two numbers, you will get 3x. So when you multiply 2 and 1, you will get plus 2. So we are going to group these polynomials or group the terms. So here we have x as a common factor. You'll take out x and you'll get x plus 2, plus you have 1 as a common factor, so you'll get x plus 2. Again we have x plus 2 in both the terms, so we'll write x plus 2 and then followed by, we are left with x plus 1. Now this is how we factorize using the splitting the middle term method, and in both the cases you will get same answers. Now let's move on to the next example, that is x plus x square minus 6. Now try to see whether this polynomial is in general, whether it is already written in the general form or not. Now the general form of the quadratic polynomial is ax square plus bx plus c. Now very important thing to keep in mind is always arrange the power, or always arrange the terms in the given polynomial in the descending order of power of its variables. That means we have to write the highest power first and then followed by the next highest and the next, and so on. So here it is x power 1 plus x square minus 6, and with 6 we have x raised to the power 0. So you have to arrange this polynomial in the descending order of its powers. So first one is, we'll write p of x is equal to x square plus x minus 6. We are done with the first step. Now the second step is, now here first we'll use the factor theorem. So you have to find all the factors of 6. So the factors of 6 are, we have plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. So now you have to find the value of the given polynomial at different values of x, and for the value of x you will choose from the factors of the constant term. So first we'll take p of 1. You will get 1 square plus 1 minus 6, which is equal to 1 plus 1 minus 6 equal to minus 4. And the next one will take p of let's take 2, which is equal to 2 square plus 2 minus 6, which is equal to 2 square is 4 plus 2 minus 6. You will get 4 plus 2 is 6, and 6 minus 6 is 0. You are getting 0 here. And next one will take p of 3, which is equal to 3 square plus 3 minus 6 equal to 3 square is 9 plus 3 minus 6, and 9 plus 3 is 12, and 12 minus 6 is 6. So let's take p of minus 3, which is equal to minus 3 square plus x minus 3 minus 6, which is equal to minus 3 square is plus 9, plus into minus 3 minus 6, which is 9 minus 3 is 6, and 6 minus 6 you will get 0. Now here we can say that x equal to minus 4 and x equal to x equal to 2. Here we have, okay. Now here the value of x is 2. When we put x equal to 2, you are getting 0. Therefore x equal to 2 and x equal to minus 3. When you put x equal to minus 3, again you are getting 0. Minus 3 are zeros of the polynomial. Therefore what we can say is x minus 2, and we have, when you move this minus 3 towards the left hand side, you will get x plus 3. Now these are the factors of the given polynomials, and we have expressed the given polynomial as a product of its two factors. Now for the same question, we'll use the splitting the middle term method. Now to use the splitting the middle term method, we'll write the given polynomial first, that is x square plus x minus 6. Now here the middle term is, or the coefficient of x is 1 or 1x. Now you need to find two numbers whose sum is 1. Sum is 1 and whose product is whose product is minus 6. Now let's take two numbers. So 6 into 1 is 6 and 6 plus 1 is 7. So your 6 and 1 will not work here. So let's take 2 and 3. 2 and 3. Sorry. Okay, 2 and 3. 2 3s are 6 and 2 plus 3 is 5. We are not getting the correct answers. Now here the product should be minus 6. So which number you are going to assign the negative sign? Now to assign the negative sign, you have to look for the middle term. Here the middle term is positive. So for the greater number you assign positive sign, and for the smaller number sorry, and for the smaller number you assign negative sign. We'll write negative here. So when you add minus 2 and 3, you will get plus 1. So what we can do is x square plus 3x minus 2x minus 6. Now 3x minus 2x is plus 1x, and 3 into minus 2 is minus 6. So here again you group these polynomials, terms in the given polynomial, and you take out the common. So here we have x as a common factor, and you'll get x plus 3, and here we have a negative as a common factor, you'll take minus, and then we have 2 as a common factor, you'll take out 2, and we are left with x plus 3. So again we have x plus 3 as a common factor, so we'll take x plus 3 and we are left with x minus 2. Now here we get the same answer. So the splitting the middle term is much easier as compared to the factor theorem. Factor theorem is easy, but it takes longer time. So with practice you can do it much faster. Okay, now let's move on to the next example, that is quadratic polynomial. Now the difference between, just observe the question and see the difference between the question that we have done in the previous two examples and these questions. All the threes are quadratic polynomials, but the difference here is, you will see that in the previous two examples we have seen that the coefficient of x square is 1. Now in this case the coefficient of x square is 12. Now here we have a difference. So what we do is, now let's take the polynomial first. We'll use the factor theorem here. P of x is equal to 12x square minus 13x minus 4. Oh, sorry. Okay, I will write the question first. 12x square minus 13x minus 4. Now here the coefficient of x square is not equal to 1. So while using the factor theorem, you have to make sure that the coefficient of x square is 1. So what we can do is, we can take out 12 common. P of x equal to, take out the 12 common. So you will get x square minus 13 by 12x minus 4 by 12. Now the constant term is 4 by 12. So you'll write down all the factors of 4 by 12. That is the constant term. So the factors of 4 by 12 are plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 1 by 2, plus or minus 1 by 3, plus or minus 1 by 4, plus or minus 1 by 6, plus or minus 1 by 12, and we have plus or minus 2 by 3, plus or minus 2 by 3, all rest all are given here, plus or minus 4 by 3, and plus or minus 4 by 6 is 2 by 3 already given here. 4 by 12 is 1 by 3 already given here. So these are the factors of 4 by 12. Now we have to check for the value of x. so that the given polynomial becomes 0. Now by looking at the questions, you can see that we have a denominator 12 in the middle term and the constant term. So we'll take the values from the fractions or the fraction numbers. So first we'll take p of, let's take 1 by 4, which is equal to, we have 12 x, instead of x we have to write 1 by 4 square. I'm using this polynomial here, and then minus 13 x equal to 1 by 4 and plus, sorry, it's minus 4. So here you will get 12, 1 by 4 fours are 16, minus 13 by 4 minus 4. So here 12 and 16 get cancelled, so you'll get 4 3s are 12 and 4 4s are 16, which is equal to 3 by 4 minus 13 by 4 minus 4. Now the denominators are not same, so we'll make the denominator same by multiplying the constant term by 4 and dividing it by 4. You will get 3 by 4 minus 13 by 4 minus 4 fours are 16 by 4. Now the denominators are same, so you will take the denominator common. You will get 3 minus 13 minus 16. Obviously this will not be equal to 0 when you solve it. So 3 minus 13 is minus 10, and minus 10 minus 16 is minus 26. Now here we are not getting 0, so I'll rub this. Okay, now let's take p of minus 1 by 4. Now this is equal to, we have 12, and instead of x you have to write minus 1 by 4 square minus 13 into minus 1 by 4 minus 4. So when you solve it, you will get 12 minus 1 by 4 square is 1 by 16, and minus into minus is plus 13 by 4 minus 4. So you can cancel these two. 4 3s are 12 and 4 4s are 16. So you'll get 3 by 4 plus 13 by 4 minus 4. Now these have the common denominator, so you can add the numerators. 3 plus 13 by 4 minus 4. 3 plus 13 is 16 by 4 minus 4, and 4 1 is 4, 4 4s are 16, 4 minus 4 is 0. So for p equal to, x equal to minus 1 by 4, you are getting 0. Now let's check for p of, let's take 3 by 4. Now this is equal to 12, so instead of x you have to write 3 by 4 square minus 13 into 3 by 4 minus 4, which is equal to 12. 3 3s are 9 by 4 4s are 16 minus 3 3s are 9, 3 1 is 3 by 4 minus 4. Now again here you can cancel the numerator and denominator. 4 3s are 12, 4 4s are 16. You will get 3 9s are 27 by 4 minus 39 by 4 minus 4. Now here the denominators are same, so you can subtract it. 9 minus 7 is 2, and 3 minus 2 is 1, that is minus 12 by 4. So 4 1 is 4, 4 3s are 12, and we are left with minus 3. So this will be equal to minus 6, and it is not equal to 0. So let's check for p of so let's check for p of, let's take minus 3 by 4, which is equal to 12 into minus 3 by 4 square minus 13 into minus 3 by 4 minus 4. So this is equal to 12. 9 by 16 plus 39 by 4. 3 3s are 9, 3 1 is 3, plus minus into minus plus and minus 4. So you will get, now this is equal to, again here you can cancel these two, you will get 3 1 is, sorry, 4 3s are 12, 4 4s are 16, so you will get 3 9s are 27 by 4 plus 39 by 4 minus 4. Now this will not become equal to, this will not be equal to 0. So let's check for another one. So I'll rub this part. Please keep in mind that for x equal to minus 1 by 4, minus 1 by 4, we have got the 0. So I'll erase all the erasing on the slide. So we'll check for, we have got p of minus 1 by 4 equals 0. So let's take p of minus 4 by 3. Now this will be equal to 12 into, instead of x you have to write minus 4 by 3 whole square minus 13 into minus 4 by 3 minus 4, which is equal to 12. So minus 4 by 3 square is, you will get 16 by 3 3s are 9, and here you will get minus into minus plus 4 3s are 12, 4 1 is 4, 5, 52 by 3 minus 4. So this will be equal to, now obviously this will not become equal to 0. So with practice you can see whether it will become 0 or not. So I'll try with another value, that is p of 4 by 3, which is equal to 12 times 4 by 3 whole square minus 13 into 4 by 3 minus 4. Now this will be equal to 12, 16 by 9 and minus 52 by 3 minus 4, and 3 4s are 12 and 3 3s are 9. So this will be equal to 4 into 16, 4 6 are 24, 4 1 4, 5 6, 64 by 3 minus 52 by 3 minus 4. So okay, so here the denominators are same, we'll subtract it, you will get 4 minus 2 is 2 and 6 minus 5 is 1 by 3 minus 4. So 3 1 is 3, 3 4s are 12 and 4 minus 4 is 0. So at x equal to minus 1 by 4 and x equal to another one is, yes, 4 by 3, 4 by 3, you are getting the value of the given polynomial 0. Therefore we can say that x plus 1 by 4 and x minus 4 by 3 are the factors of the given polynomials. So what we or this can be written as 4x plus 1 or 3x minus 4 are the factors. So now let's try to solve this question with the help of splitting the middle term method. So this kind of questions will take longer time if you use the factor theorem, and if you use the splitting the middle term, it will be much easier. Okay, now let's take a pen here. Okay, now we'll use the splitting the middle term. Now similar we have done in the previous example, that is splitting the middle term. Now the difference here is, in the previous two example we have the coefficient of x square is 1, here it is 12. So what you have to do is, now this is a, this is 13 is minus 13 is b, and minus 4 is the constant term. So what you have to do is you have to multiply A and C. A into C, you will get 12 into minus 4, which is equal to 4 2s are 8 and 4 1 is 4, minus 48. Now you need to find two numbers whose product is minus 48 and whose sum is that same number whose sum should be minus 13. Sum should be minus 13. Now you find the factors. So which two number when you multiply you'll get 48. Now we have so 16 into 3. 16 3s are 48. So you'll write 16 and 3. Now the problem here is we have negative sign on both the number. So whenever the middle term has a negative sign, you put the negative sign on the greater number. So the greater number here is 13. So you'll write 13 here, minus here, sorry, 16. Minus 16 is the greater number from the two number, that is 16 and 3. So you'll put negative on the 16. So minus 16 plus 3 you'll get minus 13, and minus 16 into 3 you'll get minus 48. So we'll write 12x square minus 16x plus 3x minus 4. So when you group this and take out the common x, you will have, sorry, not only x, we have from the number part we have 12 and 14. They have 4 as the highest common factor, 12 and 16. So we will take out 4 and we have x common. So here inside the bracket you will get 4 3s are 12, so you will write 3x, and 4 4s are 16, so you'll get minus 4. And here you there's a no common factor, or the only common factor is 1, so you'll take out 1 common and you're left with 3x minus 4. So again 3x minus 4, 3x minus 4, so you have 3x minus 4 and 4x plus 1. Now this is how we find the or factorize the given polynomial by using the splitting the middle term. So you'll find that splitting the middle term is much easier and take lesser time as compared to the factor theorem. So whenever you're asked to factorize a quadratic polynomial, you can use the splitting the middle term method. If the question asks you to use the factor theorem, then you have to use the factor theorem. Okay, now let's move on to the cubic polynomial. How to factorize a cubic polynomial. So here we have a cubic polynomial x cubed minus 23x squared plus 142x minus 120. Now here the constant term is minus 120. So you'll write down all the factors of minus 120 or the 120. So we have plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, and plus or minus 5, plus or minus 6, 7, 8, 9, 10, plus or minus 10, plus or minus 12, and then we have plus or minus 2, 10, 6, 4, 24. So all these are factors. Still there's many more factors, and plus or minus, plus you can take plus or minus 120 and so on. 120 is also there. Okay, now you have to find one factor first. So what we do is we'll use the factor theorem. We'll take p of, let's take 1. You'll get 1 cube minus 23 into 1 square plus 142 into 1 minus 120. This is equal, 1 cube is 1, minus 23, 1 square is 1, plus 142 minus 120. Now this will be equal to 1 minus 22 is, sorry, 23 is minus 22 plus 142, sorry, we'll calculate here. Okay, So 142 minus 120, you will get 22. So here you get 0. So we can say x equal to 1 is a 0. Now this implies that x minus 1 is a factor. So you get only one factor here. So what we can do is to make it easier. Now first step is must for any cubic polynomial, that is using the factor theorem. For the next step, what you can do is you can use the division of the polynomial. Since x minus 1 is a factor, so you will get the remainder 0 when you divide the given polynomial by x minus 1. So what we do is we'll divide the given polynomial, that is x cubed minus 23x square plus 142x minus 120. We'll divide this by the factor that we have just found, that is x minus 1 x minus 1. So how to divide this? We'll take the first term, that is x cubed. We'll divide this by the first term of the divisor x. So you will get x square. So here we'll write the x square. Now x square will be multiplying with both the terms in the divisor. So x square into x is x cubed, and minus into plus is minus x square. So we subtract this. So when you subtract this, this plus become minus, this minus becomes plus. So x cubed minus x cubed get cancelled. So minus 23x square plus x square, you will get minus 22x square, and we'll copy whatever is left, that is plus 142x minus 12. Now here the first term is minus 22x square. So when you divide this by the first term of the divisor, that is x, you will get minus 22x. So the sign here is very important. So you have to write the same sign, that is minus 22x. Minus 22 into x is minus 22x square, and minus into minus is plus. So 22 into 1 is 22x. Again you subtract it. When you subtract it, all the sign changes. So this becomes plus, and this plus becomes minus. So this will be cancelled, and 142 minus 22x, you will get plus 120x minus 12. Now the first term is 120. So you will divide 120. So here we have 120. Sorry, the question we have 120. So 120x divided by the first term of the divisor x, so you'll get cancelled and you get 120. So here we'll write plus 120. So 120 into x is 120x, plus into minus is minus. So 120 into 1 is 120. So here this becomes minus, this minus becomes plus, all get cancelled and remainder 0. Since we have already found one factor, now the other two factor you can find using this quotient. So here we have x square minus 22x plus 120. Now you have to find two numbers whose sum is minus 22 and whose product is 120. Okay, so we'll find two number whose sum is that is, when you add two number you should get minus 22, and when you multiply the two number you should get 120, and 120 is plus here. Multiply, you should get 120. So you'll have 10 into 12. So when you multiply 10 plus 12 is 22, and 10 into 12 is 120. But the problem here is we have negative sign here. So what we do is, since the constant term is both are positive, constant term is a positive, so when you take minus here, when you take minus here and then minus into plus, you will get minus. So you have to take both the number negative. minus 10, minus 12. When you add minus 10 and minus 12, you will get minus 22. And when you multiply minus 10 and minus 12, you will get plus 120. So here I'll write x square. Instead of minus 22, I can write minus 10x minus 12x plus 120. So we'll make a group and we'll take out x common here. You will get x minus 10, and here we have, you will take minus common and 12 as a common factor. You have x, so minus into minus, you will get positive. So here we have 10. Again we have x minus 10 and x minus 12. So the given polynomial, the factors are, we have first factor that we found is x minus 1 by using the factor theorem, and by dividing it and then by using the splitting the middle term, you got the another two factors, that is x minus 10 and x minus 12. Now this is how we factorize using the factor theorem and splitting the middle term. For the cubic polynomial, you have to use the factor theorem first for finding one factors, and then followed by the division of the polynomial, and then we are going to use this splitting the middle term for the quadratic polynomial. Okay, now this is how we factorize quadratic polynomial and cubic polynomial. Thank you.